Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, guys, we're going to be talking about Kirchhoff's second law. So put down today's title, it's going to be Kirchhoff's second law. And before we get going, guys, make sure you hit the like and subscribe button to keep my channel going and help as many kids as possible. Right, so before we start talking about Kirchhoff's second law, let's have a quick reminder of voltage in an electrical circuit. So what exactly is a voltage in an electrical circuit? Well, what about the following? Okay, so over here, guys, I've drawn this simple circuit, guys, and I put down this little subtitle, what is voltage? And obviously to explain this, I like to use the following model. So we're going to talk about a delivery service, yeah? So on one side, let's just say we've got a pizza delivery place. Let's say it's Pizza Hut. So Pizza Hut over here. And we've got a house over here. This is our house over here. And what happens is we're going to connect them via, a road. Okay, yeah, very similar, matching up to this model over here. Right, so obviously, guys, in this model, we have drivers. So these are all drivers. So let's draw drivers, guys. And they're going to walk round. And as they go past Pizza Hut, they are obviously going to pick up the pizza. And I'm going to draw it as yellow over here. And as they go past the house, they're going to deposit and give off that pizza to the house. And then they're going to walk around again. So that's my simple model. This is obviously going to tie into this one over here. So my driver, guys, what does the driver represent? The driver, so this is a driver over here, and it represents over here, so this is my driver, it represents a unit of charge. A unit of charge, guys, which is going to be 1 coulomb, everyone. So each driver represents 1 coulomb of charge. So in my electrical circuit, don't forget, we've got 1 coulomb. I'm going to draw one over here, and I'll draw another one over here, and I'll draw another one over here. So in the electrical circuit, what's going round are coulombs of charge round and round each time. Right, so just like in this model, as the driver goes round, it picks up the pizza and then walks down and drops it off at the house. Well, similarly, we have these coulombs of charge will walk past the cell and it will pick up, it won't pick up pizza, it will pick up energy. So here's the energy it picks up, and as it walks past the bulb, it will give the bulb the energy here. So as you can see, the pizza represents the energy, everyone. So in this case, on the left-hand side, guys, the yellow is the energy. I pick up the energy from the cell, I'm going to drop it off at the bulb and then go back again. And obviously in this model, I pick up the pizza and drop it off at the house. It's a very similar thing here. Right, now we're here, we can try and define what voltage is. Well, in this model, voltage is simply this. So in this model over here, the voltage is simply going to be equal to the pizza per driver. Okay, pizza per driver. So how much pizza each driver is holding. What this actually means then in an electrical circuit is going to be the voltage. It's not going to be pizza per driver. It's obviously going to be, what does the pizza represent? It is the energy and the driver per coulomb of charge, guys. Energy per coulomb of charge. So that's what voltage is. And hopefully you can now remember that we have the following equation. Voltage is equal to energy per unit charge over here. Excellent stuff. So voltage is equal to energy per unit charge. But this model helps us to understand what the coulombs are doing. They're going around and they're picking up energy and they're dropping it off over here. Now we can talk about it in terms of voltage and simple rules. Let's say we have 10 volts over here. Yeah, that's basically like having 10 pizzas over here. You pick up 10 pizzas. Okay, let's say you pick up 10 pizzas. You've got 10 here, you've got 10 here, and you're walking down. You've got one house on your route before you go back. How much are you going to drop off? Well, obviously you're going to drop off all of that 10. So that you have a 10 pizzas dropped off here. 10 pizzas here. So 10 come in, 10 come out over there. Well, obviously, going back to the electrical circuit, if you pick up 10, obviously, you're going to be dropping off 10 volts here. Excellent. Easy stuff. So look, this pizza model will obviously be able to explain how voltage behaves in a circuit like this. So it is roughly the same, guys. So make sure you have the idea of going past the battery, picking up the energy, and then dropping it off each time over here. Right, now from here, I'm just going to extend this circuit. I'm just going to move this formula over here. So let's put that over there. So voltage is equal to energy per unit charge. I'll just box that in as well over here. Voltage is energy per unit charge. Let's say right now we're over here right now, and I was to extend the circuit, I've got this. There we go. There we go over here. Right, now what's going to happen now? Well, let's just erase this and then let's just add 2 more houses and let's try and work this out then. Okay, so as you can see, I've extended this one. Right now I've put another parallel bit with 2 bulbs this time, and I've obviously drawn it onto my model diagram over here. Right, let's say we're to talk about how much voltage will be in each one of them. How much voltage will be in each one, and very similarly, how much will be over here, how much pieces dropped off here. Okay, so to explain this, let's go back to this model. You are a driver, you walk past the battery, you pick up the energy, you walk down here, and let's say you take this route. Yeah, so obviously you have to walk along that route with the pizza. Obviously I have 10 with me as I enter this branch, I drop off 10. So that's the reason why this one remains 10. But then how much pizza, if let's say for example I've gone round and I was to walk around the other one. So I take 10 pizzas again and I walk round, but then instead of going down this branch, I walk down this one. Well, logically think, you've now got 2 houses along the route and you've got 10 pizzas in your hand. So you've got 10 pizzas in your hand. I'll just draw that to make it easier for you. You've got 10 pizzas in your hand. How much will you drop off at each one before you go back? Well, you've got 10 pizzas, you've got 2 houses on your route. Obviously then you're going to drop off 5 pizzas over here and 5 pizzas over there. And then you've made your way back to the top and you're no longer fired. So you've walked all the way around again, back to the top over here, and you can start again. Right, and obviously back to our electrical circuit, this now makes sense. We can now erase this one over here and this one over here. We can then say this is 10 volts going back. This one obviously will be 5 volts over here. So as you can see guys, this model of using drivers and pizzas can help us explain how voltage behaves in an electrical circuit. So make sure we understand this. Okay, right, this will now lead us into Kirchhoff's second law. It basically summarizes the voltage rule, guys, into one nice little sentence, and it's the following. Kirchhoff's second law. In a closed loop, the total voltage in is equal to the total voltage out. In a closed loop, the total voltage in is equal to the total voltage out. As you can see in this example right now, we've stated that in a closed loop, the total voltage in is equal to the total voltage out. So look guys, let's say I have 9 volts over here. All you simply do is this. You look for the loop. So look, here is one loop. There we go, over here. And look, let's get a second loop. So that from the start, going all the way around over here. And last of all, here's my last loop with the blue over here. There we go. Right, so then you can do it step by step. So let's do the yellow one first. 9 volts come in. You pick up 9 pizzas. You walk down here. You take this route. You've got one house. How much going to drop off? It will be 9 volts over here. Easy stuff. That's one loop. The total voltage going in was 9. The total voltage out was 9 as well. What about the other loop? 9 volts come in, and look, as you walk down here, you take the second route. You've got 2 houses which are going to be identical, 2 lamps. Each one's going to take 4.5 volts and 4.5 volts over here. And there you go, this rule still applies. In a closed loop, the total voltage in is equal to the total voltage out. 9 goes in, and look, 9 comes out in total, yes, in that loop here. And last of all, in the third one, we've got 9 volts coming in, and you've got 3 different places to drop it off. Equally, you're dropping off 3 volts here, 3 volts here, and 3 volts here. So look, you can clearly see that rule applies. In a closed loop, the total voltage in is equal to the total voltage out. And you might see it in terms of mathematical symbols. The sum of the voltage in is equal to the sum of the voltage out in one complete loop, guys. One complete loop. Excellent stuff. So obviously you need to master this rule whenever you're looking at electrical circuits, guys. It's very difficult at the start because you're trying to spot it yourself, but just look at loop per loop and look at the total voltage in. It will be equal to the total voltage out in each case. Okay, so we're done for another session. Let's have a recap right from the top. Okay, so today's title was Kirchhoff's second law, and we started off with the following. I went back to revisit the idea of voltage. We defined it as the energy per unit charge. I drew this circuit over here, and I gave you the idea of coulombs of charge walking past the battery, picking up some energy and depositing it at different places, and then coming back again. This model helps us to understand it with Pizza Hut and a house and a delivery service. So each of my drivers represents a unit of charge. They go around the battery, they pick up the pizza, and they walk around and they deposit the pizza at the house each time here. And look, if you walk past the battery, you pick up 10 pizzas. In one loop, you must deposit it before it comes back. So that's the reason why you have 10 pizzas over here. But let's say I take the second route over here. I picked up 10 pizzas as I walk down. I take this route instead. I've got 10 pizzas in my hand. Obviously, I've got 2 houses over here. I drop off 5 before I come back up again. So that's this one over here. Then obviously you can tie it into voltage. That's in pizza. Now it's in terms of voltage. You've got 10 volts in. I dropped off 10. I walked back. I take up 10 volts again. I walk down here and I drop off 5 and I come back here. Don't forget what they all stand for, yes? The driver represents 1 unit of charge. The pizza represents the energy. The voltage is equal to the pizza per driver, which is basically, don't forget, pizza represents the energy per coulomb. And that's the reason why we have voltage being the energy per coulomb over here. Easy stuff. Then I gave you Kirchhoff's second law in words. In a closed loop, the total voltage in is equal to the total voltage out, or the sum of the voltage in is equal to the sum of the voltage out in one complete loop. And I drew this diagram and we looked at the voltages. So look, 9 volts coming in, 9 volts dropped off in the first loop. 9 volts come in, still 9 volts dropped off in the second loop, but 4.5 as I've got 2 of them, which total up to 9. And last of all, 9 volts come in, I drop off 3 over here. And look, that rule is valid. It still works everywhere you go in any electrical circuit. Excellent stuff. So make sure you master Kirchhoff's second law and you understand how it works. And that's it for another session of CeerazzleDazzle Physics. Make sure you hit the like and subscribe button to get my channel going, and good luck in your studies. Ciao, ciao, and goodbye.